dynamic memory is stored on something that's called the heap. And it's, again, just another set of memory addresses that we can use. When we want to create something to be placed in dynamic memory, we have to use the keyword new. So we can say, I want an integer, and then because we're creating it in the heap and with a new, we have to keep track of the address. And we keep track of addresses by storing a pointer. So I'm going to call this a pointer to an int. And I'm going to say that is a new int. So that grabs the spot on the heap. And then we can set the value. And let's assign it 3. That spot that it grabbed is a 3. Our pointer to int points to that value. And this is actually storage on the stack somewhere. That address is stored on the stack somewhere that takes us to the 3 on the heap, and we create that using a new. Now it's not very useful for just single integers, but it's very useful for allocating arrays. So let's dynamically allocate an array. So if we want to create an array of, let's do doubles for a difference, for a change. We want to create an array of doubles, and so we're going to create a pointer to start out as our starting point, giving that address. And we can just call it array pointer. And we're going to assign that to a new. We have to use that keyword new to say it's in dynamic memory. And then we're going to allocate an array of doubles of some size. So somewhere in the stack we've stored our array pointer, and it's gone to get an address from the heap that's available, and now we can have 6 values. We haven't assigned them yet, I'm just putting in data for an example. We can assign those values into that array pointer. That area is saved for the array. And so the heap just continues to grow as you allocate more and more values. Now, if we want to do those assignments, we'd use the same syntax. Array pointer 0 is 0.1, gives us the first value. And of course it would be more efficient to use a loop to go through and assign all these values into our array. And this memory is dynamic memory on a heap and not on our stack. The thing about dynamic memory is that the compiler doesn't have any idea of how much dynamic memory you're going to allocate. Now remember, we have to know the size already if we're going to allocate an array if we do it statically. The cool thing about the dynamic allocation is we can do that on the fly. So we could create an int and started out as 0, then we could read in a value as our size, and then we can allocate our array based on the size. So that gives us a lot of power to create the array that is the correct size that we need. And in fact, that's how vectors work. You know, when we learned about vectors, we learned that we could make them different sizes, that they could grow in size. Well, that's because the vector is implemented using dynamic arrays under the covers. Now, the dynamic memory is allocated manually with our keyword new, and it also has to be released manually. So I'm just going to get rid of these assignments here so I can show you how we release. If we're going to release an array, we use the keyword delete and then the special symbol of the square brackets to let it know that we want to release the whole array, and then the name of our array. And that lets us release all this memory. It gets freed up and it can be used for something else. But array pointer is still pointing at that area. And so if you messed up your code and tried to actually continue to use the values in here, they could be overwritten with who knows what. So it's always a good idea and required in this class to reassign your array pointer to null pointer after you release that memory with the delete, so that you can't accidentally go anywhere with that pointer anymore. You'll end up with a null pointer exception, and it will be easier to find any errors that you might have.